This program is presented by University of California Television. Like what you learn? Visit our website or follow us on Facebook and Twitter to keep up with the latest UCTV programs.
We have joining us Siddhartha Mukherjee, and hopefully he will pop up here on the panel. There he is. You know, I did not know until a few minutes ago that we were going to have this fantastic and important Pulitzer Prize-winning author, Siddhartha Mukherjee, on screen. I thought he was going to be with me on stage, so I rushed. As many of you know, we have a little bookstore here with people with the books of the scholars, the scientists, the social phenoms like Deepak Chopra and others. All of those books are over there. So I went over and I grabbed the book. I paid for this book, which I rarely do anymore, The Emperor of All Maladies, A Biography of Cancer. This book is arguably the most important book on cancer that has been written in this era, and we're so pleased to have the author with us. He's collaborating with Ken Burns in producing a PBS documentary on the history of cancer, the biography of cancer, and so he's here with us to have a discussion, a dialogue, and yeah, great. Greetings, Siddhartha. Hi.
Hi, how are you?
How are you? So, good to see you. So can you basically, the book you've done, which is won so many awards, is the definitive account of essentially the history of cancer from the beginning of our recorded encounters with it to the present. Can you share with us a little bit about what drove you to do this? You are an assistant doctor of medicine at Columbia University, but you are now a prize-winning author. So please share with us how you got into this and what you've learned.
Well, you know, the impetus for the book was really a question that a patient had asked me while I was trying to treat her several years ago. She said, I'm willing to go on with my next cycle of treatment, but I need to know what it is that I'm fighting. It's a very simple question. I need to know what it is that I'm fighting. And I was astounded by the fact that here we are running a presumably massive human campaign against cancer on every front, the political front, the scientific front, from basic research spanning to advocacy in Washington. And yet we lacked a kind of a manifesto, if you will, or a description, a history, a story of what was this all about? Where had this started? Is it old? Is it new? What happens next? Where are we in it? Are we in the middle? Are we at the end? And so, you know, in some ways, I wrote the book back to this patient that I was treating, but also I wrote it for myself. It was as if I needed my own roadmap and a public roadmap to where we were and what was happening next.
You know, I've enjoyed jumping around in the book this morning and looking at it, but it occurs to me that, you know, of all presidents, Richard Nixon was actually the one to formally declare a war on cancer in the early 1970s. How would you...
Richard, as you know, loved to declare wars on many things.
Yeah, there was war on many things. I was the first director of the Nixon Center, so I try to mention Nixon in every event I do. But I think that, you know, one of the questions that would be interesting for you to handicap is how has our war on cancer, how's our progress, if any, developed since then? And how do you look at this time of just, we're in UC San Diego, astounding revolutions in science and computing capacity and our understanding of genes? Do you think we're at fundamentally a different moment, that if that war were relaunched today, we would be in a different space?
Well, I think the war metaphor is a complicated metaphor, so let's dwell on that for a second. I think, you know, several people have pointed out that, you know, the idea of the wars are won or lost. scientific battles are not won or lost. They're solved or yet unsolved. So there's a fundamental conflict with the idea of declaring war on, it's like saying I'm declaring war on a puzzle. You don't declare war on a puzzle. You either solve it or you leave it unsolved or you try to solve it. So, so now turning the metaphor over to the metaphor of puzzle, I think we're somewhere in the middle of that puzzle. We have learned an enormous amount from the revolutions in biology, in particular the revolution of genomics and the capacity to detect all the genetic alterations in various cancers. Number one, we've realized that cancer is not one disease, but many diseases, that in fact, even what we call breast cancer is a whole bunch of diseases that actually are somewhat similar, but also somewhat different under the genetic microscope. And so that allows us now to have the fundamental landscape, as it were, or the territory on which, if you want to persist on the metaphor of war, the war will be fought. So in other words, we now know what the territory looks like. It's still, I think, a long way from finding out what to do about these genes. How do you now use this information to try to make therapies that don't just recapitulate the problems of the past, the somewhat effective but largely ineffective chemotherapies, the somewhat effective surgeries, the somewhat effective radiation therapy. How do you take all this information from the past and make it information about the future? I mean, the bottom line is that I think we're in the middle. We're in the middle, and it's an important middle. Wars don't get transformed. Puzzles don't get solved without going through the middle. You have to go through it. And that's where we are, and we need the energy. We need the scientific energy, the creative energy, the energy from the information systems to be able to solve the next series of important questions in this puzzle.
You know, The Atlantic has hosted quite a number of healthcare and health innovation forums. And one of the things that comes out, particularly with regard to how I've looked at your book real quickly, your book tells and links together many case studies, many human stories, history of this disease, looks at cutting-edge science, and it creates really a magnificent narrative on this disease. But the truly magnificent narrative exists out there in the health records of people that have suffered with this, the many millions who are living with cancer or who have died, who've had various treatments. And so one of the revolutions occurring today is the big data revolution. And one of the questions that has stymied somewhat those who would like to look in the case studies of all of this and look in the aggregate at everyone is concerns about privacy. Do you think that's a gap that can be jumped over? How do you respond when as a scientist, as in medicine, thinking about here you've got the availability of to take your book and multiply it by 1 million, given everything out there, and yet we've got a lot of resistance basically on the privacy front?
Well, I'm going to say two things. The first thing is that it's very important as a scientist not to confuse big data with smart data. Mm-hmm. They're not the same thing. In fact, very small pieces of data can be vastly more informative than very large pieces of data. So there's a kind of fetishism of big data, which I actually don't subscribe to. I'm not interested in it. I'm interested in data that's intelligent, in data that really provides answers to questions. And it's not necessarily big data. Small experiments can generate huge results. I mean, an apple falling from a tree on your head can be much more important than 50 pieces, 50,000 pixels of nonsense information on Facebook, say. So I think we need to discriminate between those two things. So the real question is, how do we make smart data available? And to what extent does really smart data impinge on questions like privacy and on questions like what needs to be, what needs to be kept, information that needs to be kept conserved in a way in a private space. To be perfectly honest, I really don't see a big conflict here. I mean, I think there is plenty of space for the anonymization of information such that the information does not impinge on deeply private information. I think what we're trying to do in cancer is to extract from big data smart data. How do you take genomic information of not one individual but thousands of individuals and create medicines that are better targeted, that have less toxicity, that lengthen life with fewer side effects? And it's far from clear to me that the biggest challenge there is privacy. It's just not. There's a lot of movement, as it were, in the conservation of privacy around the idea of data, and it's useful and it's helpful. But I would put it to you that that is not the biggest scientific problem facing cancer researchers today. The biggest scientific problem facing cancer research today is how to take data, which is very complex, is multidimensional, it's very big, and to convert it into things that are usable. I mean, can you use the information from the genome? Can you use the information about lifestyles to convert it into prevention? Is to convert it to identify carcinogens that we don't know about, to make new drugs happen that targets in the cell, in molecular targets that haven't been previously exploited.
Do you think there are means and methods of doing just what you said needs to happen that are emerging?
Oh, absolutely, absolutely. But I think it has to be married to what I call real biology and real medicine. So in other words, it is not clear to me that the data revolution is going to solve the cancer problem. It will provide part of the solution to the cancer problem because cancer is a complex disease, but it's not the only solution to the cancer problem. It has to be an integrated or longitudinal solution. For instance, you don't need big data to tell us that cigarette smoking is a major cause of lung cancer around the world today, which it is. What you do need is a mechanism in developing countries, for instance, to stop young people from smoking. Now, that is not a data problem. It is a problem about the way we deploy data, the way we understand social networks. I'd like to discriminate between big data and between smart data. You might have a single intervention might be successful in transforming the prevention of lung cancer in developing countries. Now, where does that information come from? It might come from the extraction of information from very complex social networks, or it might be an advertising campaign that is actually based on something that was done in the 1950s. So again, just to emphasize the point, let's not confuse big with smart.
Great, that's a great point. You write in your book, section I love this section, the philosopher of science Karl Popper coined the term risky prediction to describe the process by which scientists verify untested theories. Good theories, Popper proposed, generate risky predictions. They presage an unanticipated fact or event that runs a real risk of not occurring or being proven incorrect. When this unanticipated fact proves true or the event does occur, the theory gains credibility and robustness. And then through this chapter, you talk somewhat historically, looking back at those people who made risky assessments that began to kind of help fill out our understanding of the story and history of cancer. And I'm interested, given all the narratives that you've sewn into this and your profound knowledge now of how we've evolved. Today, looking forward, how do you see what what are the risky predictions that we would posit from this time in 2013 that might be the ones to challenge our own understanding and paradigm of thinking about cancer?
So it's a deeply important question you're asking, and so let me propose some risky predictions, and I encourage people in the audience actually to think about their own risky predictions, because this is how science moves ahead. So in other words, what's a risky prediction? A risky prediction is a hypothesis that runs a real, tangible risk of failing to be true. In other words, it's very easy to come up with hypotheses that are likely to be true, right? And as Popper and others have pointed out, the real driving force of much of science is to put your neck out there and to make a prediction that truly runs the likely to be not proven true and thereby proves or disproves theory. This goes back to the idea that Popper had of the idea of falsifiability, which is that theories are only useful if they're truly falsifiable. If you propose a theory, you have to be able to propose an argument or an experiment that will disprove the theory. And just to give you one example to fill this out, I mean, you can't say, for instance, alternative medicine really works in cancer, but unfortunately, using your metrics, I'm afraid you won't ever be able to prove it, right? So that's a theory that does not have a risky prediction, because essentially you've taken the risk out of the prediction. You've said there's no way you can prove or disprove it. So let me give you some examples of some risky predictions. Number one, deep genomic annotation of cancer. That means sequencing cancers at a very deep genetic level is going to have a transformative impact on cancer medicine and prevention. That's a risky proposition. In other words, you're saying that big information about all the genetic mutations that cancer has will, in the end, provide new mechanisms of treatment, cure, and prevention of cancer. We don't know this yet. We would like to believe it's true because we've invested a huge amount of resources scientific personnel and political resources into the Cancer Genome Project. And the question is, what are the dividends of that project? Will it really transform into true new medicines appearing in the horizon? So that's point number one. Here's another risky prediction. The understanding of the immune system and its relationship to cancer will provide a new set of diagnostic and therapeutic tools in the future. Maybe it's true. In fact, we're beginning to see the first few amazing new cancer drugs that specifically target the immune system, activate it, and make it active against cancer cells. But we don't know if these will really ultimately become common. Are these common targets? Are these uncommon targets? Is it true for all cancers? Not true for all cancers? That's a big question. Here's a risky prediction number three. Combinations of therapies that are targeted against particular genes or genetic pathways, if you combine them, you all of a sudden will get synergistic and huge effects that single therapies don't have in themselves. It's a risky prediction. We don't know if that's true or not. We know in general that combination chemotherapy, which kills cancer cells relatively indiscriminately, can have a huge impact on some cancers, but on other cancers it's not very effective. So is it true that targeting multiple pathways using much more these novel therapeutics will have a series of impacts on cancer? I'll give you one last example, and this is a political example. Altering the structure, the way we perform cancer research currently, which is based on a model of academic research being translated by translational physicians and ultimately by the pharmaceutical industry in a kind of linear manner, will produce the next generation of cancer prevention and therapeutics. Now, you could say, well, it generates a risky prediction. Are there other models out there that would actually work better? Could there be a more superior model that produces a more transformative impact on cancer therapy in the near future? So these, that's just a spectrum, and I could go on. I could give you tens of thousands of, probably not thousands, I would say dozens of examples of truly risky predictions that span the gamut from basic science to the political organization of cancer research.
I think that kind of list is really vital, in part giving people an on-ramp to understand what the cutting edge of thinking in this area is doing. So such a list is such a valuable thing. Your book is not only a...
And Steve, let me pause for a second. Yeah. Who do you think should generate that list?
Well,
who is in the position? Is it a public responsibility? Is that list to be crowdsourced? Does it require a public conversation? If so, who is having that public conversation? How's that public conversation being funded? I mean, we understand the importance of the problem. 1 in 3, if not 1 in 4, if not 1 in 2 men and women will be afflicted by cancer in their lifetimes in the United States. 1 in 4 men and women will die of cancer. This is your problem. This is my problem. This is our children's problem. This is our parents' problem. So what are the mechanisms of having this conversation? Who is having it? And who are the critics of this conversation? Who is surveying and scrutinizing this conversation?
Great question. I think that the follow-up I was going to have on that was that your book is not just a story of cancer, it's really a story of society and how it's mobilized to think about it and deal with it. And one of the interesting questions I have today, particularly what we see going on with Washington. Washington is not the be-all in this, but we're at a world-class research facility here. You work in a world-class hospital and research university yourself. And in this, when you look at the ecosystem that's been developed over time, the stakeholders, the innovators, the scientists, the funders, the Bayh-Dole Act, which gave universities a stake in advancement of science and economic incentive. I'm interested in how someone, because you know this world much better than I do, how would you say we're doing in terms of building a stronger ecosystem, and do you see that, an ecosystem of dealing with this question, and do you see it enhanced by what's going on now, and we can either talk about Washington or not, or do you see some of the key elements of that social stakeholding in this being undermined?
Well, I'm happy to talk about Washington, although it's a depressing conversation. So, it
won't be my last question, so we don't have to end in a low.
I think is that it's a fragile ecosystem. Like all important ecosystems, we have to recognize it's a fragile ecosystem. What you cannot do, and I've been to, like you have been in Washington several times, what you cannot do with cancer is you cannot say, or with any scientific project, you can't say, well, we've run out of money today, so let's put it on hold for 5 years, and when the budgets creep up, when the time happens, we'll come back to it. That just doesn't happen. Science is a continuous conversation. And if it breaks, it's a broken conversation. So it is not as if you can all of a sudden say, well, let's put the cancer genome on hold for the next 5 years, and when we come up with the right set of tools, we can come back to the conversation, because that conversation will cease to happen. There are people who are deeply engaged in the conversation right now, and that includes scientists, epidemiologists, nurses, advocates, patients, their loved ones, their families, and it is a continuous conversation. It's happening right now. It's a fragile conversation because it can be broken by, if you cease to have it, then it will forget, and in fact you have to build it up right from scratch. So, and there are institutions, national institutions, that have spent their entire lifeblood, as it were, to keeping this conversation happening. The National Cancer Institute, the National Institutes of Health. So it is a peculiarity of this ecosystem that while it produces rich dividends on one hand, it's actually very fragile, and it can be very quickly harmed by, take away a few of these critical pieces, and the whole thing comes toppling down.
Just before I move to the audience for questions, I guess my last question is about the documentary, the 3-part, 6-hour PBS series that you are doing based on the Emperor of All Maladies. There's a way, and I love the way you framed it, this is really a chronicle of us. It's a chronicle of people in their lives, forcing them to look at it. But what I see your book doing, and the discussion we've had today, is really one, to inspire or to drive collaboration to kind of continue to work on this. So how are you and Ken Burns thinking of organizing the series, and what is your ultimate objective with the series on cancer?
Well, the ultimate objective is to start a national conversation about cancer, and through that, start a national conversation about science, and through that, start a national conversation about the relationship between society, illness, medicine, and science. It's a large goal, but I think cancer itself is a phenomenon that involves us all, so therefore is I think the appropriate substrate to have that conversation. The way that we're doing it is that we're trying to tell stories. I think of myself, I think of scientists as storytellers, I think of physicians as storytellers, and I think of myself as one of the many storytellers in this process. I think it is a story, it is our story. It is a story because it is something that affects each and every one of our lives. If you look at Ken's films, Civil War, jazz, baseball. Civil War is a film about the Civil War, but it's really it's a film about our contemporary story today. Baseball is a film about baseball, but it really is about the story of aspiration and tragedy of aspirations. Jazz is a story about music, but it's also a story about race and its consequences in the United States. So in some ways, cancer, I think, will be a story about cancer, but it will be a story about much larger themes: wellness, illness, normalcy, abnormalcy, what it means to be a society where, as I said, 1 in 3 or 1 in 4 people will be affected by this illness, and how we deal with it historically becomes a fundamentally American story.
Thank you. Let me open to the audience. We've got time for a couple of questions. Let me take this gentleman here.
Good morning, Dr. Mukherjee. Daniel Simon from Onyx Pharmaceuticals.
Hi, Daniel.
If you look at the difference in cancer outcomes across countries, across states, hospitals, and indeed individual physicians, it would seem that one of the biggest improvements today in oncology outcomes would be to get all physicians to adhere to best practice as we understand it today. How should we think about actually making that happen?
So the question is, how should we create best practices, or how should we make physicians adhere to best practices? Because they're two different things.
Adhere to best practices and adopt them.
So the first part of the question is, how do we create best practices? How is there a mechanism to create best practice? So here it comes back to a risky prediction, right? The risky prediction here, which I think is worthwhile thinking about, is, can one create a series of best practices such that when you go to your physician, in the United States, in the United Kingdom, wherever you're being treated, that you know that you're undergoing the best practice treatment, and then the alternative is a clinical trial that moves that best practice in some ways. Now, the reason I'm saying this is very important, because the revolutions of new therapeutics will not be realized in cancer medicine, in adult cancer medicine, unless adults participate in trials. And adults will not participate in trials unless they're told that what they're being treated with is state of the art, but has reached a kind of plateau or a limit or a ceiling, and that the next level of knowledge generation involves a clinical trial. Right now, we have about 10% participation of adults in clinical trials. The number varies depending on the disease, but that's a dismal number. That's an abysmal number. We cannot undergo the next series of important advances in cancer medicine without involving at least 50 or 70% of patients in developed countries in clinical trials, and maybe in developing countries as well. So I fully agree that there has to be a creation of a best practice system that allows cancer medicine to move forward. Let me make one other point clear, which is that a best practice system need not even be the most economic practice system. And we have to discriminate between these two things. The most cost-saving solution may not be the best solution, but we need to have a conversation about which is the better solution for us as a society or a healthcare system. Is there an intermediate point which saves cost and is most effective for the amount of cost given? I think these conversations are so vital, and that the fact that we're not having them, instead are spending our time talking about nonsense in cancer, how to fund and how move forward the most basic science, because we cannot manage to fund a basic national cancer effort is really depressing to me.
Well, just to wrap up, Siddhartha, I just want to thank you for this book, and thank you for helping us to know our own narrative of something that I think all of us have been exposed to and think about, that we experience in our lives. And I think it's such a great and valuable contribution. I really recommend everyone. We do have the book outside The Emperor of All Maladies. So thank you so much for this
Thank
morning.
you so much. And,
Yeah.
and my last message is don't let anyone convince you that this is someone else's problem. This is your problem. This is my problem. It's a national problem. We need to solve it. Thank you.
Ladies and gentlemen, Siddhartha Mukherjee.